Welcome student, welcome to our YouTube channel Chemistry Table. If you want to get a good mark and secure 80 out of 80 in your class 10 board examination of the ICSE, I will assure you watch all the videos from this YouTube channel. I will cover all the chapters of chemistry part wise. This is the part 4 video of the chapter 2 chemical bonding. So after completion of each chapter, I'll discuss so many question and answers that includes the previous year question answer from your textbook, okay, and for so many definition and the concept. I'll also create the shorts. You can check the shorts portion as well as the playlist. In playlist, we already have the chapter 1, so many parts. So if you cover all the parts of the previous chapter 1, then I'll assure you you have a crystal clear concept of this chapter. So try to cover all the videos from this YouTube channel. So today we will discuss the part 4. So this is my request to all of you. First learn the part 1, part 2, part 3, then watch this video. So today our concept is condition for formation of covalent bond. In the previous part 3, I discussed all the concept for your board class 10 ICSE about the covalent bond. Today I will discuss the conditions. Now try to understand. Suppose if any atom, suppose this is second or outermost shell, suppose there is one electron, then tell me an innermost, suppose 1 2 3 4 5 6 7 8. Suppose look at the board, first shell contain 2 electrons, second shell 8, last shell 1. So now it is looking like 281, that is sodium. Okay, forget about the element, just try to understand the concept first. Tell me, to get the stability, this atom will try to what? Lose or accept. So it try to lose. Okay, all of you know what is covalent bond. Covalent bond means formation of this common space. Both the atom donates the electron here in the common space. This is called the general concept of covalent bond. You can watch the previous video. I cleared all the concept based on your syllabus. So now these atom lose. So the donation of the electron is not the concept of covalent bond. Covalent bond means formation of this common space. It will donate one electron and form cation. Okay, now if there is 2 electron, it is also donates. Suppose like magnesium means 12, so it will try to lose to get the stability. Suppose outermost shell 3 means it will also try to lose to gain the stability. Now look at the board. If any element, suppose you consider this is the last shell, I draw the last shell, 1 2 3 4 5 6 7. Another element, there is also 1 2 3 4 5 6 7. How they will get stability? Obviously by accepting one electron, but it is not possible here because who will give the electron here? Both the atom needs to accept some electron, but no atom are available here to donate them. So that's why what they will do, they will try to create this common space. So try to understand the concept. Whenever the 2 or more atoms try to accept the electron, but any other atoms are not available to donate the electron. For example, here 7 electrons. Suppose in previous case, in outermost shell 1 electron like sodium. So look at the board. If these 2 elements try to form the bond, it needs 1 electron and it will try to lose 1 electron. So it lose and it accepts, so they can form ionic bond. But here both the atom try to accept the electron, but suppose no other elements are present here. So in that case, they will form this common space. Now how many electron they will try to accept? 1. So instead of accepting, they will try to donate. It donates also 1, it also donates 1. So previously it was 7 electron, now 1 2 3 4 5 6. 1 2 3 4 5 6. Why? Because 1 donates each. So how many electron pairs? 2. That is 1 electron pairs, but 2 electrons are here. So that's why suppose it is atom A and it is B, so A and B can form bond. This bond is known as covalent bond. So from the previous concept you already understand, if outermost shell 3, 4, 5, 6, 7, 8, if outermost shell 1 electron is present, it will just donate. Donation does not mean formation of covalent bond. If 2 electron, also donate, 3 electron is also donate. So now if 7 electron, then both the atom contain 7 electrons, so they will try to form the common space. So keeping in your mind first condition of the covalent bond, if the outermost shell contain minimum 4 or 5 or 6 or 7, this type of electron, then the atom has a tendency to form covalent bond. So you can note down this concept. What is the first condition to formation of the covalent bond? The outermost shell of the atom, both the atom should have 4, 5, 6 or 7 electrons. Okay, now point number 2. From the concept of covalent bond, all of you know both the atom try to form the common space. Okay, now do you know what is electron affinity? Electron affinity means try to accept the electron. Now in this case A bond B, both the atom are present. Okay, here suppose in previous case outermost shell contain 1, 2, 3, 4, 5, 6, 7. Okay, another atom there is also 1, 2, 3, 4, 5, 6, 7. So tell me what they will do. They will form this type of common space. So tell me, is it possible they will donate the electron? No, it is not possible, because rather than donation they will try to accept, no, to formation of the octet, that is the 8 electron in the outermost shell. So try to understand electronegativity or electron affinity. What do you mean by electron affinity? Like that, there is 7 electron, it will try to accept, completely accept, is known as electron affinity. Now another concept is electronegativity. What do you mean by the electronegativity? Already I discussed in the chapter 1. Electronegativity means suppose AB bond, 2 electrons are present. If one atom pull the electron towards the itself, see, previously the electron present at the middle, if any atom try to pull the electron towards itself, so it is called electronegativity. So both of these concepts are more or less similar but not same. Electron affinity means completely accept the electron in the shell, completely accept. It will not accept, it will just pull towards itself. So but more or less same. Why? Because it's also accept, I mean try to accept, it also try to accept towards it. Okay, so now tell me, my next question or next concept is that in case of this type of covalent bond, they will try to lose electron? No. So they will try to bind the electron in the common space. A also donate electron here, B also donate the electron here. So they will not lose, they will bind the electron in the common space. So electron binding means electron affinity. C accept the electron. Electronegativity means also pull the electron, strongly pull, that is bind the electron. So second and third condition, high electron affinity, high electronegativity, because both the term indicates try to hold the electron, not lose, try to hold. So see, in the covalent bond the electron hold here in the common space. Do you understand? So these are the most important conditions, 3 conditions. Okay, now next, 4th conditions. Do you tell me what is ionization energy? Ionization energy means the amount of energy required to remove these electron from the outermost shell. Again, the amount of IE, ionization energy, the amount of energy required to pull the electron, that is take out the electron. Tell me, in covalent bond, the atom in the covalent bond, is it possible for the atom to lose the electron? No, they will hold the electron here. So suppose if you try to take out the electron from the outermost shell, you cannot, first of all, because they will try to hold the electron in common space. You cannot pull out. But if you try to pull out, you need more amount of energy. Huge amount of energy is required to pull the electron. So in case of covalent bond, high ionization energy also required. Okay, because you cannot pull out, or these atom not try to lose the electron. So if you try to take, you have to give more energy. Do you understand? Done. Last and final condition. Tell me, in the covalent bond, they will form this common space. Okay, but suppose two atoms are there, electron present at the middle of the bond. Now suppose the electronegativity of these atom are such that this electronegativity of the atom in these OS, look at the board, suppose these atom B try to pull this electron towards itself. Again, if the electronegativity of this atom B is such that the electron pair present in the bond pulled by the B completely. So all of you know charge of the electron is negative. So since negative charge move towards B, so it gets negative charge, it gets positive charge. Try to understand, it is looking like dipole. I discuss in the part 3, dipole, but it is not covalent bond. Covalent means electron, look at the board, it is A, it is B, electron present at the middle, but this is covalent, middle. But if one of the atom try to pull, it is not covalent atom. So what is the last condition? The electronegativity of the two atom in such a way that both have more or less same or zero difference in electronegativity. Again, give focus. If both have same electronegativity, electronegativity means try to pull the electron. If both have same or more or less zero electronegativity, electron present at the middle. But if one has more electronegativity, pull towards it. It is not covalent. It is covalent. So what is the last condition? Both the atom have more or less zero or zero difference in electronegativity. Done. These 5 conditions are very, very important for our board ICSE class 10. Now, if you open your textbook, concise, one of the best book for your board examination. If you observe the question from the previous year, you will see that the question, most of the question, not most, all the question from the book concise, that is Selena. If you open the concise, then our next topic after condition, that is given in concise, one note is given. This note is very important. You cannot get such type of explanation in anywhere. So observe this video properly. In concise, this note statement is only written. No explanation is there. What is this statement? As we move across the period, that is across the period in this way, periods. As we move across the periods, then electronegativity of oxides and chloride decreases. Okay, electronegativity. Okay. okay, no, wait, as we move no here here actually the statement is as we move across the period, then electrovalent character, this is character of oxide and chloride decreases. This statement is given but no explanation is given. Look at the board. Tell me as we move left to right. So if I consider the first element, suppose it is not the first shell, don't make this mistake here, don't do the same mistake. It is the, I consider it is the valence shell, that is the last shell. So as we move left to right, last shell contains suppose 1 electron, then 2, then 3, then 4. Suppose here 1, 2, 3, 4, 5, 6, 7, and the previous 1, 2, 3, 4, 5, 6. So first 1, then 2, then 3, 4, 5, it is 6, it is 7. So now can you tell me which has these two, among these two atoms, which has between these two atoms first and last extreme to end, which has more non-metallic character? I discussed in the chapter 1. Non-metal means, so that's why it is important to watch this video one after one sequential pattern, then you can clear all the concept. Now come to the concept here. Between these two extreme atoms, which has more non-metallic character. Non-metal means acceptance of electron. Look at the structure here, outermost shell contains 7 electrons. So it will try to accept 1 electron. Why? To fill up its octet. No. So now it is metal. Slowly metal changes to non-metal. Metal, non-metal. So now non-metal means acceptance of electron, that is pulling the any other free electron. Look at the board. Suppose this is non-metal marked by N. It is metal marked by M. So if M form bond with oxygen, see oxide and chloride both are same, I choose the oxygen as an example. Suppose here metal form bond with oxygen. Here metal form bond, sorry, here not metal, here non-metal form bond with oxygen. So now what is electrovalent character? Electrovalent character means ionic character, that is this one. The bonded electron present first at middle, then it pulled by any one of the atom. Pulled by any one of the atom. This concept is known as electrovalent character or ionic character. Now tell me here metal. Metal means lose the electron. So here since metal has the character to lose the electron, so metal try to lose towards the direction of oxygen and oxygen try to pull. So see, one atom pull, then it is called electrovalent character. So it is electrovalent character. But now what is non-metal? Non-metal try to accept. So look at the board. If oxygen try to pull, non-metal also try to pull. Because non-metal has a tendency to accept the electron. It also pull, That's why electron, there is a no movement of electron. It will be at the middle or more or less at the middle position. So electrovalent character of the oxide and chloride C decreases. This is the complete explanation. Understand? Okay. Done. Now again, if you open your textbook, we have so many compounds. The formation of, heading is formation of covalent compound. We have so many examples. In this part I will discuss 1 to 2 examples, and in rest of the example I will discuss in the part 5 video. Look at the board. According to your concise, the first compound is hydrogen. Okay. Orbital diagram is not in our syllabus. So if this type of question will come, draw the structure of the formation of covalent compound, then don't draw the orbit, that is orbital diagram, because it is not in our syllabus. So what you have to do? You have to do in this pattern. You have to follow this manner. Look at the board. Covalent. So covalent means again common space. Common, C for common, C for covalent. So hydrogen. What is the electronic configuration of hydrogen 1? How many hydrogens? 2. Okay. So tell me, to fill up its duplet, how many electrons it require? 1. So it will try to accept 1, but who will give? Another atom is present, but it also try to accept. Both the atom has the tendency to accept, but no atom are available here to donate them. So that's why both the atom try to accept. So they will try to form this type of common space. Okay. So now this H 1 electron, this H 1 electron, give the arrow, give bond. These 2 electrons come close to each other and form this bond. So this is the covalent bond. Do you understand? Okay. So this is our first compound. Very, very easy concept, nothing is there. Now, if I consider the second compound, suppose chlorine. First practice hydrogen and chlorine, okay? Because hydrogen behave like a, it's also accept electron, so it behave like a non-metal. So hydrogen, I choose the hydrogen from the first, that is the left hand side of the periodic table, and chlorine the extreme end, that is group 17. I discuss all the position where the chlorine and the what is the position of hydrogen and chlorine. So read and watch, make your own note, part wise, chapter wise. Go to the playlist, chapter 1 are there, so many parts are also there. So one after one complete this part. Okay, now formation of covalent compound chlorine. Chlorine, how many, what is the electronic configuration? 287. So how many electrons are present in outermost shell? 7. Another chlorine, also 287. Don't draw the orbit, it is not in our syllabus. So without drawing this orbit, how many electrons present here? 7. So give 7 dot 1 2 3 4 5 6 7. Here also 1 2 3 4 5 6 7. Okay, so since both have the tendency to accept, so what they will do? They will form a common space. Okay, so chlorine, these 2 electrons, suppose this chlorine donates 1, so remain 1 2 3 4 5 6 here. Here also remain 1 2 3 4 5 6. Okay, I give this blue dot 3 4 5 6. So it is donated by in common space by the 2 chlorine. So what is the next step? These 2 chlorine, these 2 electron form this bond. Now what is about, so these 2 electron form the covalent bond. So what is about the rest of the electron? How many pairs are available here? 6 electron means 3 pairs. So these 3 pairs form lone pair over the chlorine atom. So how many bonded pair? It is called bonded pair. Bonded pair 1. How many lone pair of each chlorine? 3. Here also 3. So this is the full concept of the covalent bond condition. And the one note, this note is very, very important. So practice first hydrogen and chlorine. In next chapter I will discuss more difficult one, ammonia, water, so many concepts. Okay, so prepare your own note. For more question answer you can join our WhatsApp channel, link given in description box. Okay, thank you.